Hi, welcome to the first video for CS 4050. And calling it a video is really kind of an exaggeration. It's really just me talking while I write out some stuff. So this video is about the brute force design technique. Oops. So the idea of brute force is that you create a tree of all the possibilities. And the reason we do a tree instead of a list is because the tree helps us to think about decisions. So a lot of the problems we're going to study in this course are involve decisions. Like the sorting problem is kind of atypical. Most of the things we'll study are what's the best way to do something. When you have a list of things to sort, they're either sorted or they aren't. So it kind of, you can put it in the same frame of mind if you think like, is there a way to put these in order or something? But basically, most of the things we'll do, the tree works really well. So the first example I want to work through is permutations. And there's one example written out. I should have said this video is for pages 1 through 3, not very long, in the course notes. And it's the document named bruteforce.pdf. Okay, so I just wanted to go through like the n equals 3 case. So permutations means all possible words where the order matters. So all possible rearrangements of 3 symbols. So to do the tree, we start out with the root node. And at that point, we've made no decisions. And so the first decision, there's different ways to do all of these brute force things, but the first decision is, hey, maybe I could use an A. And that n equals 3 just means we're just going to use 3 distinct symbols, so we'll just use A, B, and C for convenience. Or maybe I could use a B, or I could use a C. And now in each of these nodes in the possibilities tree, we can think, having made that decision, what's the next decision? The next decision, of course, would be you could do an AB, or you could do an AC. And similarly, this could be BA or BC. And this could be CA or CB. Okay, now notice I did not put in AA, and that would have been perfectly okay, but then we would have pruned that and said no. So the idea of pruning we talk about on the last page of the notes is as you're building the tree, sometimes you're building the tree in a way that you get nodes that don't lead anywhere, so you just chop them off and say don't go any farther. Other times we'll be able to save a lot of work by noticing that the approach we're taking, the choice decisions we've made up to some point actually are clearly going to be worse at the end than something else we already know how to do. You'll get to explore that on the a little bit on the 0-1 knapsack problem in lesson 2. So continuing with this, so I'm going to just rub that all out. So continuing with this, if we've decided to use A and B, there's only one more choice, which is to use C. So and here we get ACB, BAC, BCA, CAB, and CBA. So if you read these in left to right order, those are all the permutations of 3 symbols. And in fact, they're written in a sort of in a traditional way, canonical way. I mean, we could have done the same tree, like saying what's the last symbol, the second to last, and the first symbol, and we would have gotten a different looking tree, but we would have had the same final desired result. Okay, and one of the issues here, let's see if I can remember how to go to another page. I think I hit plus. Yay. Okay, so we want to put all the info in a node, not along a branch. So the reason for that is it makes programming it easier. So on the project one I'm going to ask you to do, and on the example code that's out there somewhere we'll talk about later, it's if you have a node containing certain data, you can, and that has children in the possibilities tree, if all the data is in the node, then you can just have a method that takes in that data and and you can have a method call that takes in these as arguments and then generates method calls for each of the children. So we want to have the information like right there handy in the node, because then we can just turn those into arguments for the method typically. So a bad way to do this would have been to say ABC and then say choose B or C, choose A or C, choose A or B, and then choose C, B, C, A, B. I mean, I barely even know what I'm doing here, and it's kind of confusing. The point is, then you have to read down a branch to find out that this is ABC. The way we did it, so this seems easier, but it's less productive, definitely. Okay, so I'm going to go ahead, since we have time, I'm going to go ahead and do the embedded exercise 1, but I want you, this is super important, I want you to turn off stop or pause the playing of this video and do embedded exercise 1. So embedded exercise 1 is to do the permutation tree for n equals 4. So if you'll honestly, on these embedded exercises, if you'll just take a minute with a piece of paper and a writing utensil and try to do it yourself before you start the video up again, and I tell you how I think you should be able to do it. Okay, welcome back. Hopefully you did it, but let me just quickly run through it. So here we have A, B, C, D. Then we'll have AB, AC, AD, BC, BD. Whoops, BA. Forgot what I was doing. CA, CB, CD, and then it's DA, DB, DC. And then here we get ABC, ABD, ACB, ACD, and so on. I'm getting bored with this. ADB, ADC, and then so, etc. And then from ABC, there's only one possibility. It's just ABCD. This one would be ABDC, and so on. So it's too much like work, and I didn't have space on the page to write it. So you probably found out the same thing if you were actually doing it. So now is a really important embedded exercise 2. So this asks you to look in the folder code, and in that folder you'll find a method called perms.java. So download that file from the course website and look at it and do some sample runs and play around with it. Make sure you do like n equals 3 and n equals 4 to see that it does exactly what we've got, and then you might want to do like n equals 10 to see that the efficiency of this algorithm is pretty horrible. Of course, it takes something like n factorial steps to compute all the n factorial permutations of n symbols. Okay. The important thing to notice is what I was talking about up here, is that it's all about method calls. We don't literally build the tree. Okay? And when you've done that, start up the video again. Okay, welcome back. Like I really think you're doing this, but maybe you are. So embedded exercise 3 asks you to do another, actually I'm going to erase that and we'll go to a new page to be tidy. Okay, so embedded exercise 3 asks you to form all words of length k from in symbols. And the specific problem is n equals 3, which means you use the symbols a, b, and c, and k equals 2. So pause the video and take a minute to try to do that possibilities tree, and then we'll go on. Okay, welcome back. Hopefully you did something like this. So the first symbol we could use is A, or we could use B, or we could use C. And now the second symbol we could use here would be AB or AC. And here it would be BA or BC, and here it would be CA or CB. And then we're done. And for n equals 4, let me see if I can squeeze that in here. For n equals 4 and k equals 2, we would do A, B, C, oops, D, and then we'd have AB, AC, AD, BA, BC, BD, CA, CB, CD, and DA, DB. My brain isn't working very well. DC. Okay. So the last page you might want to look at talks about pruning some more, and this will be a big topic as we go on. We'll do stuff like we'll solve the traveling salesperson problem toward the end of the semester, and pruning will be super important. The idea is if you've got a possibilities tree, the best thing that can happen is you're cranking through all these possibilities, and you don't have to do them. You can go depth first, and then if you find a good way to do something, then that can sometimes prune, and you don't have to actually pursue, because in some way you can tell from finding one good way to do something that all these others are bad, and then maybe we have to come back up here and pursue some other things, but it can save a lot of time. And as you're working on the problems in lesson 2, you want to be aware of the pruning. Basically, you can either not write nodes down in the first place that are not going to go anywhere, or you can write them down and then stop pursuing them, like I was talking about on the original permutation. So that's the end of this first video, and I hope it all actually recorded and stuff. So I'll see you on Monday.